I might as well say this so Bailey can hear it. So, yes, if the journal question is improper integrals are integrals that what? Why are they improper?
Limits that go
Have undefined barriers.
Yeah. So you can put it that way. They're limit. You can tell me if they have limits that typically go to infinity or create undefined values. So they don't appear to be possible when you initially look at the problem. So while you're writing, all right. Is there a way to divide by zero? Not specifically divide by zero. Can we use a limit to determine what is happening as we approach that value and get very close? Yes. Can you actually divide by zero? No. I mean, we know it means usually normal, in most instances, dividing by zero means it's either headed to positive or negative infinity. So, if you have like junior high siblings, do they know what infinity is?
My junior high sibling isn't intelligent enough to discuss math.
I learned infinity in second grade.
Or the game where everybody was trying to say the biggest number and then it was neutral. I say infinity and then you automatically win.
All right, so you tell me, how am I going to work this problem? I need to put a limit on it, all right? A limit as L approaches what? Negative infinity. And so therefore I'm now integrating from where to where? L to 1. And then I have this lovely function. Now the question is this an easy integration or is this a pain? It looks a lot like yesterday's partial fraction problem. So the question is it something I can U sub or do I have to do an inverse tangent on it? Since there's an x on top, yeah, I should be able to U sub this. Like I said, they're not going to give you mean and vicious integrations here. But if you would like me to do that, I can do that.
Do what?
Give you mean and vicious integrations in your improper integral problems. Okay, so yes, this one's going to come out quite nice. I'm going to have, my x is going to get canceled here in a second. My bottom is now just u. And I have adiosed my x's. So what's actually left?
Can we pull that 1/2 out in front of everything?
I would, yes, actually, by everything, you can either stick it in front of the integration, or you actually can stick it clear in front of the limit. Both would be correct.
All the way up in front.
You want the 1/2 clear in front of the limit?
Yes, ma'am.
Okay. Either place is legal. I don't care. In the end, we'll have to take it times a half, whatever final answer we get. So what's left to actually integrate? Yes, you have to realize that's just 1 over u. You're going to see a lot of those because natural logs result in lots of undefined values. So I now have to do a limit on a natural log. Yeah, baby, but don't forget you have to sub the limits of integration in. That tends to be a step we want to skip. We forget that,
That's not a real answer. You go to negative infinity at a natural log.
You're jumping ahead of me. Hold on.
Well, I'm just angry.
Is it a less valid answer if it turns out to be something that goes to infinity and diverges? Is that less informational?
Yes.
You still found out what this function's doing.
That's true.
So it's not like it's a bad answer. It's not a normal, nice, easy answer.
How fast is it diverging?
Okay, so when I sub my numbers in, I'm going to have the natural log of 1 minus the natural log of L. Okay, I need you all to realize, if you haven't already learned this, what the natural log of 1 has a numerical value that's really easy. It's 0. You remember graphs of logs, they cross the x-axis at 1, so that means the y-coordinate is 0. Natural log of 1 is 0. So that baby just...
The log of negative infinity is impossible.
So that baby just left us. Now, I will tell you, on some of these, if you get a natural log of something like 2, 3, anything other than this 1, you might have to use your rule about subtracting logs is really dividing. So I could have turned this into the log of 1 over L, since that was subtraction there. And on some problems, you may have to do that. But in this case, we don't. All right, so the 1/2 is still sitting here. I need to know what happens when I try to take the limit of that. I got 1/2. Okay, when I put negative infinity in there, I'm actually going to write this out. You have a negative natural log of absolute value of negative infinity. So that's a positive infinity, isn't it? So what's the natural log of positive infinity? I just drew the picture. When x goes to positive infinity, where's y going? Infinity. So in the end here, I actually end up with 1/2. Now, this negative's out front, so that didn't go away. That's the negative times infinity, which actually gives me an answer then of what? When you multiply all three of them. Negative infinity, and so I would therefore say that this one converges or diverges? This one diverges. Okay, you will probably find it helpful. You remember those lovely limits that you had memorized a while back about what e and natural log do at various numbers? You might find that useful to recall, okay, what did e do when it went to negative infinity? It goes to 0. But when e goes to positive infinity, it's infinity. Whereas on the other hand, when natural log can't go to negative infinity, natural log can go to 0 from the right side only, and it can equal negative infinity, whereas when natural log goes to positive infinity, you get infinity, yes. Okay, anytime they go to positive infinity, the whiteboards go to positive infinity. But when they're going to negative infinity or 0, that's where you have to watch out. But you might find those helpful to kind of stick in your back pocket as, oh, I might use those.
So, if you're given a rational expression in which the highest power of the numerator is greater than the highest power of the denominator, you should do blank before trying to break it into partial fractions.
Oh, we didn't talk about that. I'll come back to that. Let me finish this. Remind me of that.
John, I don't have enough room on my
I forgot to say that on partial fraction day. It's because I've had students come back from college and they had to do this, so I need to say that to you. Alrighty. It's one with going from negative infinity to positive infinity. Yes. Boil it?
Yeah. Then you substitute it.
Yeah, but first what do I have to do with the fact that I have negative infinity and positive infinity?
Break it out.
Yes, this has to break into two integrations with two limits. So I work left to right, so I start at negative infinity and say L to where? L to 0. You actually can do it L to 1 and 1 to L. You could actually do any number you want. And they typically use 0 because it's an easy number. But yes. Classic, really. It's never one of my favorite animated I had to watch with my kids. Oops.
What is your favorite animated movie?
I love Hercules.
I did like Hercules. But did anyone else notice the humor of it when they made him plunge through the river Styx? You know how you're supposed to lose your soul? Yeah. Who's the ginger? The joke from them.
Never would have thought of that one. Okay, this one's going from where to where? This one's going 0 to L. Okay, and like I said, the good news is the integration of this is the same exact thing for both of them. You don't have to work the full integration twice. Do the integration once and then just say the other one changed into the same thing. So I would use substitute. 4. Yeah. So u is x to the 4th plus 4, which means du is a convenient 4x cubed. Golly gee, do we like that.
Oh, we love it.
Well, particularly when we have an x cubed sitting in our problem, we sure love that. Okay, so I have x cubed over u squared du over 4x cubed.
Yep. Cross out those x cubes.
Cross out those x cubes.
Pull out your 1/4 away this time.
Okay, and here we actually need to make a decision as well.
We pull out a one.
We pull
We pull out a 1/4.
We pull out a 1/4. Okay, we also have the option of, it's currently in u's. Where this u is a quantity, we can change our limit.
No. Do it on your own time, Naomi.
I hope you don't. Because if you do it, all you're going to do is stick 0 up there and go, oh, 0 plus 4, that changes to a 4.
It ain't gonna happen.
Stick L in there. You got L to the 4th plus 4. So I can change my limits, and then I never have to ever substitute back in. I can just integrate it.
We're substituting back.
No, fine, change them.
Change it. I dare you. I dare you.
Well, mathematically, I think they're going to expect you to change them. I was expected to change them. So we need to make sure we can change them. So if I put 0 in there, you're putting it in for x, you're finding out what u would be. 4. That's not that hard. You put L in there, L to the 4th plus 4, didn't it? Yeah, you just put that in there. It's not that big a deal. No, nothing fancy. That's simple. All right, now, so I'm pulling the 1/4 out. I'm doing what with the u squared?
Oh, bring it up.
Yeah, it's got to become u to the -2, and then, yes, I need to integrate it. And so, can we do that in one step? Can we integrate it and move it back to the bottom? That would be lovely. Okay, so I'm having fun here. Got my L to -infinity. Can't write. And so, whoops, rid of the sign because I'm actually integrating. So yeah, it would be u to the -1 over -1. But it's really then just -1 over u, if I drop it to the bottom, from L to the 4th plus 4 to 4. Okay, then last but not least, we got to sub the numbers in and do the limit. Yeah, but the second half is a massive shortcut now. Once you've done one side, you don't have to do this all again for the other. We'll be able to shortcut. I'll show you in a sec. All right, so if I sub the numbers in here, I'm going to have -1/4 plus -1 over. Could you all hold on for like 5 more minutes?
I'm talking about how awesome my hair is going to be.
We're more worried about our improper integrals.
Actually, I'm kind of worried about graduation.
I can make that more worrisome.
Did you? Wow. I'm pretty sure all of us are going to pass even if we fail the final.
If we fail everything, why not make a discussion?
Unfortunately, I don't have control over your graduation, darn it. You've already passed 3 math classes.
Yeah. Oh, yeah. All of it. Now, finish your trip, that's different.
Yeah, I do. I'll take you to Legoland. I'll take you to Legoland. It's a little kiddie park where you play with Legos and stuff.
Covered in Legos.
Okay.
It's the worst place ever to go barefoot.
I am. So if you actually do your limit here and you stick -infinity in there to the 4th power, that's positive infinity, isn't it?
Yeah.
So adding 4 on makes no difference to it. So I have -1 over infinity, which makes that go to, that whole thing, that part goes to 0. This part, 0 plus 1/4 though, that's still there because that's a plus sign. So what's this actually become? -1/16. Okay, but you're not done. Why?
Literally 10 minutes of learning math left in your life.
Before you whine and complain, let me show you the shortcut. Isn't that the exact same function you just integrated?
it's -1/8.
So you can copy it down to go down here to where the limit is and say, oh, okay, it's plus this limit as L approaches positive infinity now, but what would have changed? I maybe should have had you go one step before that. I probably should have had you go to one step before that. Because I'm going to infinity, what were my limits on this one? Since it was 0 to L, you'd have had to sub in 0 in here, so that would be 4. You'd have subbed L into the U substitution, so it would be L to the 4th. So what you have to realize is that stuff was on the top, so when I sub it in, I'm going to have -1 over the L to the 4th plus 4 comes first. Then I'm subtracting a -1/4. So it basically it would change your signs is the big thing it's going to affect. All right, so now do limit.
No. Yelled at me.
-1 over infinity
You're gonna get 0.
is going to be 0 plus a 4th.
That means you're probably landing.
And so
So it's just the opposite sign?
a good portion of the time it's the opposite sign and it adds up to 0, but not always.
So we always
Sometimes you'll get an actual answer. But a lot of times, yes, it will add up to 0.
I've learned your ways, Ms. Meyer. You always say there are those little exceptions, but you never actually put one on the
I think you have something in this assignment, if I remember right. So, converges or diverges?
Converges.
Converges. Okay, the other thing you need to realize, if you do one side and it does go to infinity, it diverges. Is there a need to work the other side?
Oh.
No. If one side diverges, you're done, it diverged.
What if the other side is the second side going to diverge? No.
What if it's -infinity plus positive?
I knew that was coming. Then you have a situation of back to, you remember those indeterminate forms of not knowing which way infinity was going to pull?
We got to do that.
No, we are not. I actually don't think I remember seeing one do that. Theoretically, it's probably possible, but I can't tell you I've seen it. Okay, to answer that question you just asked me about the partial fraction that I forgot to say to you on partial fraction day. I'm asking you, what would you do on a partial fraction on your journal? Because I had some people come home from college, Calc 2, and go, we had to do this. And suppose it was divided by x squared plus 1 or something. No, it'd have to be more than that. X times x squared plus 1, because you would have to be doing partial fractions. Okay? What would you do? I should have written that the other way, though. I should have made that x cubed plus x. You haven't factored it yet. Okay, clearly the numerator has a higher power than the denominator. That's not supposed to happen. So if that would happen,
Couldn't you just use substitute then? You could.
not have it cancel,
Oh, yeah, you're right.
won't cancel. But what they would actually have you do, it turns out this would divide into that, and you would get some whole expression, and then the remainder would be a fraction. So yeah, if this happened, you would have to do long division first, where you're gonna get x. You're gonna get x plus some fraction. I know I'm not gonna give you one of these. You're gonna get x. It'll go long division. You'll get an x plus some fraction. So you would integrate the x, and then you would have to do partial fractions on the rest. I am not going to do that to you, and I don't remember them really doing that to me in college, but somebody in the last few years came home and said, yeah, they made us do that. So you would have to do long division first and then break the rest into partial fractions.
Alex, you just come home and make up a whole bunch of lies and calculator